The session. Today we are going to see few problems under the chapter of mechanics of rigid bodies. So already we covered few problems under this chapter. Now today we are going to cover few more problems. See, so here one problem is a cube of side length A and mass m as shown in figure. Coordinate axis coincides with the sides of cube. Find the inertia tensor matrix. Now let us take here cube. Here I am taking cube. Okay, so this here axes are coincide with the sides of cube. Now what I am assuming, this is what x axis, y axis, z axis. This is O, here x, y, z coordinates I am assuming. Okay, now let us see here. Initially let us assume small element whose volume is dx dy dz. Okay, whose volume is dx dy dz. Now so here mass of that volume, mass of this small volume element can be written as dm is equal to rho density into volume dx dy dz. Now the total inertia along the x direction, can be written as, the formula is like this: Ixx that is equal to triple integral, and here you have to take rho into dx dy dz, rho into dx dy dz into, we have to write here y square plus z square, okay. Now y square plus z square. What are the limits here? Limits goes to sides are length of this side is a, here it is a, and here it is a. Okay, then limits goes to 0 to a, 0 to a, 0 to a. Now we have to solve this inertia. Now let us solve this function. Here we have to separate the integral components. Let us write here rho outside the cube, outside the integral, and now I am splitting from 0 to a, here it is dx, and here 0 to a, and here 0 to a. Here we have to write y square plus z square into dy dz. Okay, now initially what we have to do, we have to integrate this one. If you integrate this one, integration of dx will become x. Now substitute limits 0 to a. After substituting, what we get? A will get. Okay, so rho into a, again integrate with respect to y. Okay, so 0 to a, integrating with respect to y, what we get? So integration of y square dy will become y cube by 3. Okay, so we will get y cube by 3. So one more term is what here? Dz remains same. Okay, so dz, otherwise we write dz outside only. Next, here what we get? Integration of dy will become y. So z square 5. What are the limits? 0 to a. Here it is what? Dz remains same. So again substitute a value. What we get? Rho into a, and after substituting a value, what we get? 0 to a. Here we will get a cube by 3 plus, here z square remains same into a dz. So again integrate with respect to z. What we get? Rho into a, integrating with respect to z, a cube by 3 into z, and plus z cube by z cube by 3 into a, and the limits goes to 0 to a. Substituting limits, what we get here? Rho into substituting limits, what we get here? Rho into a. Here we'll get a to the power of 4 by 3 plus here we'll get a to the power of 4 by 3, and finally ixx will get here rho into a to the power of 5 by 2 a to the power of 5 by 3. Again we'll write this one as, see here, rho into a cube and 2a square by 3. This is equal to mass. Then we'll write 2 by 3 m a square. 2 by 3 m a square. Okay, this is what ixx. Next we are going to find out ixy value. Next iyy we have to find out. Okay, then how can we get iyy? See here, iyy. So iyy. So here we'll get, take similarly ixx 0 to a, 0 to a, 0 to a, and here you take rho into dx, dy, dz, and the components are x square plus z square, x square plus z square. Now integrating this one, what we get? We'll get similarly ixx value, and let us separate the terms. Rho right outside, integral 0 to a dx, and double integral 0 to a, 0 to a, and x square plus z square into dy dz. Again integrating this one, will get rho into a. Here, so after integrating this equation, what we get? Sorry, here you have to write this is what y, okay, y, and this is what dx dz, okay, dx dz. Okay, after integrating, what we get? 2a to the power of 4 by 3 will get there, and finally rho into 2a to the power of 5 by 3. Again this can also be written as rho into a cube to a square by 3, and final will get iyy is equal to 2 by 3 m a square. So this is one function. Okay, and similarly izz. Let us see how can we get izz. Here also we'll write a 0 to a and 0 to a, 0 to a. Okay, and here you write rho into dx dy, this mass of the element, and you will write x square plus y square. There is no z square component because we are finding inertia along the moment of inertia along the z direction. Okay, again we have to write this one as a right rho outside, and 0 to a into dz, and 0 to a into dx dy, and x square plus y square. So after solving this one, what we get? We'll get rho into a. Here we'll get 2a to the power of 4 by 3, and final we'll get rho into 2 by 3 a to the power of 5. Again that can be written as rho into a cube and 2 by 3 a square. The value of this one is mass of the element. So we'll get 2 by 3 m a square. So till now we got only ixx, iyy and izz. Next components are ixy, ixz. Okay, so let us find, how can we find ixy here? Ixy. So ixy is equal to iyx. This can be, we'll find this one like this, minus triple integral 0 to a, 0 to a, 0 to a. Here you write mass element, mass of the element, rho into dx dy dz, and here you take the components xy. Okay, xy. Now integrate this one. Write rho outside, and integrating with respect to dz, we'll get z only, and substituting limits will get a. Otherwise you write first initially 0 to a dz, and 0 to a x dx, and 0 to a y dy. Okay, so solving this one, what we get? Solving this one, what we get here? So we'll get, substitute the values, minus rho into, here we'll get a, and this one is x square by 2, we'll get a square by 2 into a square by 2. So finally we'll get minus rho into a cube into, right, a square by 4, and we'll get minus m a square by 4. This is what ixy and iyx. Okay, this is one value, right? And the next value, what we are going to find out, the next value is iyz. So iyz and izy, that is equal to minus triple integral limits 0 to a, 0 to a, 0 to a. Here what we get, rho into dx dy dz, and here the remaining term is zy. Okay, zy, and integrate this one. What we get, integrating minus rho right outside and 0 to a, and we have the term dx and 0 to a, okay, y dy and 0 to a, z dz. Okay, and solving this one, what we get, minus rho, and here it is a, this one will become a square by 2, and this one will become a square by 2. Finally we'll get minus rho into a cube into a square by 4. Okay, so finally we'll get minus m a square by 4. So here also yz and izy is equal to how much, minus m a square by 4. Okay, so next term is izx, ixz, that is equal to minus triple integral 0 to a, 0 to a, 0 to a. Here you take rho into dx dy dz. Okay, dx dy dz, and substitute, and here the term is, remaining term is xz. Now integrate this one, minus rho right outside and 0 to a, x dx, and 0 to a only dy, and 0 to a z dz. Integrating this one, what we get here, integrating this one, what we get here, minus rho into, this one will become a square by 2, and this is what a, and this is what a square by 2. Finally we'll get minus rho into e to the power of 5 by 4. So that is equal to minus rho into a cube into a square by 4, that is equal to minus m a square by 4. So finally we got here izx, that is equal to ixz is equal to minus m a square by 4. Okay, so we got all the values. Let us substitute in matrix. Okay, see what we get if we substitute in matrix. Here you know that inertia matrix can be written as I equal to, it contain 9 components, ixx, ixy, ixz, iyx, iyy, iyz, and izx, izy, izz. Okay, substitute all the 9 components here, that is equal to 2 by 3 ma square, here is minus ma square by 4. Okay, minus ma square by 4, and the remaining term is what, minus ma square by 4. Here it is minus ma square by 4, here is 2 by 3 ma square, and here minus ma square by 4, here minus ma square by 4, here minus ma square by 4, here is 2 by 3 ma square. And take ma square common, what we get, taking ma square right outside the matrix, we'll get here 2 by 3 minus 1 by 4 minus 1 by 4 minus 1 by 4, 2 by 3 minus 1 by 4 plus 1 by 4, and so here we'll write minus 1 by 4, 2 by 3. So this is our required inertia matrix tensor. Okay, inertia matrix tensor. So this is our resultant one. Now let us move to the next problem. Now let us see the next problem. What is that? A cube of mass m and side length a is rotating about x-axis with the angular velocity omega. Find the expression for angular momentum and kinetic energy. So we know that L can be written as L is equal to I omega. L can be written as L is equal to I omega. Okay, I omega. Okay, so we know that L is a vector. This, it has three components only. L bar is equal to Lx I cap plus Ly j cap plus Lz k cap. Here omega bar also, it is a vector which contain only three terms: omega x I cap plus omega y j cap plus omega z k cap. So but what happened here, inertia term which contain 9 components, we know very well it is a tensor. So in that case, now here Lx can be written as Lx, comparing LHS and RHS terms, will get Lx can be written as Lx is equal to Ixx omega x plus Ixy omega y plus Ixz omega z. Okay, but we know that here the cube is rotating about x-axis only. So in that case, so here omega y and omega z goes to 0. Angular velocities along the y direction and z direction will become 0. Now what happened, this equation reduced to Lx is equal Ixx omega x. Okay, Ixx omega x. But here we know that what is Ixx value. Okay, let us see that one later. And what about Ly? Here Ly can also be written as I yx omega x plus I yy omega y plus I yy omega z. But here we know that yy and omega y and omega z will become 0. Finally we'll have the term Ly equal to Iyx and omega x. And similarly, what about Lz term? Here Lz can also has only x component Izx and omega x. Here we got three components. So this is one component, and this is one component, and this is one component. We got three components. But from the last previous equation we got there Ixx value is 2 by 3 ma square, and here yx value will be minus 1 by 4 ma square, and Izx value is how much? Minus 1 by 4 m a square. We got three values, and substituting here what we get, and Lx will get, Lx can be written as Lx is equal to 2 by 3 ma square and mod omega bar. Here Ly can also be written as minus 1 by 4 ma square omega bar. So Lz is equal to minus 1 by 4 ma square. Here we'll get right omega bar. These are the Lx, Ly, Lz. Now substitute in total angular momentum vector. So total angular momentum vector will be what happened here, and L bar is equal to, substitute these values and take ma square and omega bar common. What we get? 2 by 3. Substitute this one in here in this equation. So what we get here? 2 by 3 I cap minus 1 by 4 j cap minus 1 by 4 k cap, and taking ma square omega bar common. This is what total angular momentum when the cube is rotating about an x-axis. Now what about its kinetic energy? We know that kinetic energy, now here the cube is rotating around the x-axis, and the kinetic energy, how can we write kinetic energy of rotating body? K is equal to half I omega square. Here we'll write 1 by 2 Ixx omega x square. What is Ixx? 1 by 2 into, here Ixx will be 2 by 3 ma square into omega x square. So 2 can cancel, we get 1 by 3 ma square omega x square. So this is what kinetic energy of rotating cube around the x-axis, Okay, this is our required solution. Now let us move on to another problem. So now the next problem is, see there 4 point masses each equal to m are placed at points A00, 0A0, 00A and AAA. evaluate the inertial tensor for this system. Okay, so that means we are going to find out inertia tensor matrix. Okay, inertia tensor matrix. So what is that? Here we'll write inertia tensor matrix which contain 9 components. What are they here? Ixx, Ixy, Ixz, Iyx, Iyy, Iyz. Here Izx, Izy, Izs. So which contain 9 components. Now we have to find out all these 9 components. Okay, so let us see how can we find. Let us first write all the 4 points here. A0 0 and 0 A0. Here 0 0 A and A. Okay, these are the 4 points. Now let us assume here these points x1 y1 z1, x2 y2 z2, x3 y3 z3, x4 y4 z4. Okay, so let us assume. Now first find out here Ixx inertia along the x direction. So how can we find inertia along the x direction here? See summation, this can be written summation I mi, your components are y square plus z square, y square plus z square. Now here mass of all points is same, so write m outside and now expand this function. Expanding this function, what we get? Y1 square plus z1 square. Okay, y2 square plus z2 square. Next y3 square plus z3 square, y4 square plus z4 square. Okay, and substitute all these values. Here we have the values. Y1 square plus z1 square is how much? 0. Okay, plus y2 square plus z2 square. Here y2 square z2 square only will get a square plus y3 square plus z3 square. Y3 square plus z3 square will get a square plus y4 square plus z4 square will get a square plus a square. Finally we'll get 4m a square. 4m a square. This is one value. Next Iyy. What we get? Summation I mi, and here we'll get x square plus z square. Again you have to expand this one. What we get? M into x1 square here, z1 square plus x2 square plus z2 square plus x3 square plus z3 square plus x4 square plus z4 square. Substitute all these above values. Then what we get? M equal m into x1 square is what? A square. What about z1 square? 0. x2 square? 0. What about z2 square? 0. What about x3 square? 0. What about z3 square? A square. Plus here we will have a square plus a square, and finally we have 4m a square. 4m a square we have. And similarly here Izz, summation I mi and xi square plus yi square. Okay, again you have to expand this one. Then what we get here? M into x1 square y1 square plus x2 square plus y2 square plus x3 square plus y3 square plus x4 square plus y4 square, and substitute all the values. Will get m into x1 square plus y1 square. Here we'll get a square plus x2 square plus y2 square. Here we'll get a square, and x3 square y3 square, it is 0, plus x4 square plus y4 square, a square plus a square. So finally we'll get 4ma square. So this is the required values Ixx, Iyy and Izz. Now we have to find out Ixy, Iyz and Ijx values. Let us see how can we find that values. Here now we have to find out I xz, that is equal to izx, that is equal to summation. So I mi, here we have the term zi xi. Okay, zi xi. Now substitute, expand this function and take m common, then we'll have z1 x1 plus z2 x2 plus z3 x3 plus z4 x4. So what we get here in this equation, finally substitute all the values z1 x1 and z2 x2 and z3 x3, then we'll get here only 0. This one is 0, this one is 0. Here we will get only a square will become, here you have to write minus ma square. Okay, minus ma square. Similarly, what about iyz minus summation I mi zi. Okay, from using this one, write m outside and expand y1 z1 y2 z2 plus y3 z3 plus y4 z4. Substitute all the values, will get minus m into 0 plus 0 plus 0 plus a square, will get minus ma square. Similarly, I here is equal to izy. Okay, next I, the next term is what, I xy equal to iyx. Okay, so here we'll get minus summation I mi xi zi. So what we get here, minus m, writing outside, expand x1 y1 plus x2 y2 and plus x3 y3 plus x4 y4. Substitute all the values, will get minus m into 0 plus 0 plus 0 plus a square, will get minus ma square. So we got all 9 components here. Substitute in the matrix. So I equal to, after substituting here, so what we get, ixx. What is ixx? What value we got ixx? Here ixx is 4ma square, right? 4ma square. So 4ma square. Next ixy is minus ma square, and ixz value is how much, minus ma square. And similarly here iyx, where is iyx? Here it is. So minus ma square, this is what, 4ma square, this is minus ma square, and here minus ma square, here minus ma square, 4ma square, and take ma square common, writing outside I equal to, so what we get, taking writing ma square outside the matrix, will get 4 minus 1 minus 1 minus 1 4 minus 1, and here we'll get minus 1 minus 1 4. So this is our required answer. Okay, so now let us move on to another problem. Okay, see this problem we are going to solve now. What is that? Four masses of mass small m are placed at points a 0 0 0 b 0 0 0 c and a b c. Find the inertia matrix of the system. Okay, we are going to find out tensor matrix, inertia tensor matrix of the system. See, 4 different points are given. So what are the points here? A 0 0 0 b 0 0 0 c and a b c. Okay, let us assume these terms as x1 x2 sorry x1 y1 z1 x2 y2 z2 x3 y3 z3 x4 y4 z4. Okay, now inertia matrix tensor. Okay, inertia matrix, inertia tensor matrix. How can we write? I equal to, it contain 9 components, just like previous problem. Ixx, Ixy, Ixz, Iyx, Iyy, Iyz, Izx, Izy, Izz. Okay, now so we have to find out all these 9 components. See how can we find all these components here. So first component, inertia along the x-axis, Ixx equal to, so write down summation I. So mi, here you have to write y square, yi square plus zi square. There is no x component in that, because we are going to find only inertia along the x directions. So in that case, right, all the points, all the masses are same, that is equal to small m. Write m outside. Okay, and expand this function. So we have 4 points, right? So that means you write here summation I yi square plus zi square. Now we have to expand this summation. So what we get here, m, and expanding that function, y1 square plus z1 square plus y2 square plus z2 square plus y3 square plus z3 square plus y4 square plus z4 square. Substitute all the terms above from above given values. Y1 square plus z1 square, here it is 0. Y2 square plus z2 square, here this one also 0. And y2 square plus z2 square, here we have only b square. Y3 square plus z3 square, here we'll get c square. And y4 square plus z4 square, here also we'll get b square plus c square. Finally we'll get 2m into b square plus c square. Okay, we got only one value, Ixx value. Okay, now similarly Ixy equal to, sorry, Iyy, what, how can we get Iyy value? Summation I mi, here xi square plus zi square. There is no y component because we are going to find out inertia along the y direction. Now write m outside I, here we have xi square plus zi square. Okay, now expand that function. What we get after expanding this function, x1 square plus z1 square, x2 square plus z2 square, x3 square plus z3 square, x4 square plus z4 square. Substitute all the given values, and x1 square is what? A square. Z1 square is 0, and x2 square 0, z2 square 0, x3 square 0, z3 square c square plus x4 square and z4 square, a square plus c square. Finally we'll get 2m into a square plus c square. Okay, similarly we'll get Izz equal to 2m into a square plus b square will get, a square plus b square will get. And next what we have to find out? We have to find out these values, Ixy, Ixz and Iyz values. Okay, let us see how can we find this one. Next, Ixy, that is equal to Iyx, that can be equal to minus summation I mi, you have to write xi yi. Okay, And what we get, substitute right mine m outside and expand that function, will get x1 y1 plus x2 y2 plus x3 y3 plus x4 y4. And what we get here, minus m into this term is 0 plus 0 plus 0 plus, here we'll get ab, that is equal to minus m into ab. And similarly what we get, I yz, so I zy, that equal to minus summation I mi zi yi. Now expand this function, minus m right side because masses are same, and you write z1 y1 plus z2 y2 plus z3 y3 plus z4 y4. So substitute these values, minus m is equal 0, here will get 0, and this term 0, this term will become what, z4 y4, means we'll get cb. Okay, so finally minus m into bc will get here. Okay, next similarly what about I zx, that is equal to I xz, so minus summation I mi xi zi. Okay, now so write m outside, minus m into x1 z1 plus x2 z2 plus x3 z3 plus x4 z4. Okay, substitute all the above values, minus m into 0, it will become 0 0, here we'll get a into c, finally minus m a c. Okay, now we got 9 components. Substitute in inertia matrix tensor. So I is equal to, so ixx, in case of ixx we got there 2m into ixx b square plus c square. Here it is ixy, so here we got minus 2 into ab, right, minus 2 into, sorry, m into ab, here we'll got minus m into ac, right. So here we'll got yx, that means minus m ab, here we have the function 2m into a square plus c square, here minus yz value, yz minus m bc, here izx value minus mac, and here we have zy value minus mbc, here it is 2m into a square plus b square. And from this equation take constant terms outside, here we'll write m writing outside, see what we get. If you write m outside, we have 2 into b square plus c square minus ab minus ac minus ab, and here we have 2 into a square plus c square minus bc minus ac minus bc, and 2 into a square plus b square. This is our required matrix. Okay, so in this way we'll solve all the problems. Okay, in the next session we are going to start a new lesson, that is what, central forces. Okay, we are going to see the topic. I think you understand very well. So this is the problem. Then how can we solve? We solve all these 9 components. So by using the inertia formulas, Ixx can be written as summation I mi yi square plus zi square. Similarly Iyy and Izz. Okay, and also here Ixy and Iyx, we will use this one, Ixy Iyx minus summation I mi xi yi square, and expand this function, substitute all the values, will get this one. And similarly Iyz, so formula is minus summation I mi zi yi, so here is the formula, here is the answer. And here this, for this components, minus summation I mi xi zi, so we got here this one, and substitute all these 9 components inertia tensor matrix, will get this function, this equation. Now this is the matrix, inertia tensor matrix. So this is an important problem. Okay, so in this way we'll solve problems.